Hello students, how are you all doing? Hope that you must be fit and well. Today we are doing a sum from JEE Advanced 2015. The sum reads like this. Let yx be a solution of the differential equation 1 plus e to the power x y dash plus ye to the power x equals to 1. If y0 equals to 2, then which of the following statement or statements are true? Okay. Now there are four options to this question answer are given. Okay, out of these four, there may be more than one correct answer. So we have to find all the correct answers of this question. The first A is y minus 4 is equals to 0. Okay, y bracket minus 4 equals to 0. That means y value when x is equals to minus 4, the y value is 0. B is y minus 2 equals to 0. That means the value of x when the value of x is minus 2, the value of y is 0. Yx has a critical point in the interval open interval minus 1 0. That means not included minus 1 and 0. The yx has a critical point. That means there is some solution for the differential equation. Okay, there is some solution of the y. Okay, that means that there is some solution of y when the x value lies between minus 1 and 0. Okay, and fourth D, yx has a critical point in the interval minus 1 0. Okay, has no critical point, sorry, the yx has no critical point in the interval minus 1 0. That means y has no solution, okay, in the open interval minus 1 0. Okay, so we have to find the correct answers for this question. Okay, so how we will do it? See here, this is the differential equation given to us. So this is, we are writing it like this: y 1 plus e to the power x y dash means dy by dx plus y into e to the power x is equals to 1. Now divide throughout with 1 plus dividing, okay, dividing throughout by 1 plus e to the power x. So when we are dividing throughout with this, so this will cut out. So we will have dy by dx plus e to the power x divided by 1 plus e to the power x is equals to 1 divided by 1 plus e to the power x. So, here it is y also. Dy by dx plus e to the power x divided by 1 plus e to the power x into y equals to 1 divided by 1 plus e to the power x. So this differential equation is a linear differential equation. Here the y coefficient is the function of x, and here the constant, here this side, this is also a function of x. So this is the linear differential equation. So this is solved by finding the integrating factor. So integrating factor is what? E to the power, here the y coefficient, okay, e to the power x divided by 1 plus e to the power x into dx. So here this, so we have to solve this integration. So how we will solve it? Let, I am taking here, let I1 is equals to integration of e to the power x upon 1 plus e to the power x dx. So let 1 plus e to the power x, I am assuming that this is equals to z. So on differentiating both the sides, what we will have? E to the power x dx will be equals to dz. So this I1 will become e to the power x dx is equals to dz. So that is dz by z. So that is equals to log z. Okay. So the integrating factor is log z, and z is what? Z is 1 plus e to the power x. Okay. So that is equals to log of 1 plus e to the power x. So integrating factor, I have showed you what is the integrating factor. Okay. So this is equals to, okay, so this is equals to e to the power log, I have showed you integration of this. So that is 1 e to the power log of 1 plus e to the power x. And e to the power log any quantity is that quantity. So this will be equals to 1 plus e to the power x. So that is the integrating factor. So when we have found out the integrating factor, so what will be the solution of the differential equation? So the solution of the differential equation will be then y. So solution of the differential equation will be what? Here will be equals to y into integrating factor. So integrating factor is 1 plus e to the power x equals to, here the constant term, what was the term here? Okay, so into that integrating factor. So here it was 1 plus e to the power x. Okay, so multiplied that with integrating factor. Okay, and that integration. So this is equals to y into 1 plus e to the power x is equals to what? Here this will become dx. So this 2 will cut out plus c. Okay. So that from here what we are getting? So from here the solution become y into 1 plus e to the power x is equals to x plus c. Okay. So let this differential equation is the general differential equation. So we have to convert it into the means definite solution. Okay, this solution is the general solution. We will convert it into the definite solution. Okay, how? By putting x equals to 0 here, y0 is equals to 2. That means the x value, when x value is 0, the y value is 2. So putting y equals to 2 and x equals to 0 in equation number 1. Okay, here it is given to us in the question. So here I am putting y value to 1 plus e, x value is 0. 1 plus e to the power 0 is equals to x value is 0 plus c. Okay, so this become 2 into 1 plus e to the power 0. Any number to the power 0 is 1. So that is equals to c. So this become, okay, so c is what? 2 into 1 plus 1 is 2. So 2 into 2 is 4. So c value we have got 4. So the solution becomes then solution. What is the solution then? The solution of this differential equation become, okay, y into 1 plus e to the power x is equals to x plus c. C value is 4. So that is the definite solution. Okay. Now here the solution becomes this. So now we have to see the options. Okay, so I am converting this into like this form. So this become y is equals to x plus 4 divided by 1 plus e to the power x. So now we will check what the options given. So A was telling us that when x y minus 4, here it was given y minus 4 is equals to 0. That means when the x value is minus 4, the y value is 0. So here when we are putting x equals to minus 4, okay, so putting, okay, x equals to minus 4, so what we are getting, y is equals to minus 4 plus 4 divided by 1 plus e to the power 4. So minus 4 plus 4 is 0. So 0 divided by any number is 0. Okay. So this option A is correct. And B option was what? Telling to us. The B option is telling that y minus 2 is equals to 0. That is when the x value is minus 2, the y value is 0. Now check it by putting, so y, if I put x value minus 2, okay, so minus 2 plus 4 divided by 1 plus e to the power minus 2, okay, e to the power any number is never 0, okay, and minus 2 is always a positive number. E to the power any number is always a positive number, never 0 and never less than 0, okay. So this become 2 divided by a positive number. So that is not equals to 0. So y value is not equals to 0. So the B option is not correct. Okay, so A is correct and B is not correct. Now we will check the means C and D option. Out of these, okay, whether they are correct or not, let us check. So the C option was telling that yx has a critical point in the interval minus 1, 0. That means there is some solution of this this equation. Okay, there is some solution of this equation in the interval minus 1 and 0. Okay, so there is some solution of this equation at minus 1, 0. Okay, so let us now check it. Okay, now here we differentiate this equation. So we are telling this equation as the equation 2. So differentiating the second equation, so what we will have, dy by dx will be equals to here what we will have, differentiate this, the numerator, okay, so this numerator differentiate, this will be 1 into the denominator, okay, so denominator is 1 plus e to the power x, 1 plus e to the power x minus the numerator, okay, into the differential coefficient of the denominator, which is e to the power x whole divided by 1 plus e to the power x. Okay, now for having a critical point, what is the condition? The critical point condition is that dy by dx should be equals to 0. So the critical point condition is that dy by dx should be 0. Okay, now we have to check that whether this is having a critical point or not. So for this I am taking, so this become 1 plus e to the power x minus e to the power x into x plus 4 divided by what? 1 plus e to the power x. So let us assume the numerator, okay, as gx, a different function. So let gx is equals to 1 plus e to the power x minus e to the power x into x plus 4. Okay, so now see here. So what we have now, okay, So this is we have assumed that the numerator is a function gx. Okay. Now here put the value. Here we have to check that whether y has a critical point at -1, means in the open interval -1 0. Is there any critical point in this interval? That means leaving -1 and 0, all the points between -1 and 0. Okay, so now see here, g -1. So when I am putting x value -1 here, so what I am getting here? So this become 1 plus e to the power -1. X value I will put -1. Okay. Now minus e to the power -1 into -1 plus 4. X value I am putting -1. So that become 1 plus e to the power -1 plus, sorry, here it is minus. Okay. So this is minus e to the power -1 and -1 plus 4 is 3. So that become 1 plus e to the power -1 minus 3 e to the power -1. Okay. So what we are getting? We are getting that this become equals to 1 minus 2 e to the power -1. Okay. So that become 1 minus 2 e to the power minus e to the power -1 means e. Okay. So this value, e value is what? E value is greater than 2. E value is something like 2.8. Okay. So it is, e value is greater than 2. Okay. So this 2 divided by a number greater than 2 will be less than 1. So this will be what? This is less than 1 and this is 1. So this will be greater than 0. Okay. And g0. So when I am putting the value of x equals to 0. So what we will have here? 1 plus, okay, e to the power 0. Here I am putting the x value 0. So this in the function of gx. Okay, so this will become 1 plus e to the power 0 minus e to the power 0 and x value I am putting 0. So 0 plus 4. Okay, and e to the power 0 is 1. So this become 1 plus 1 minus 1 and this becomes 0 plus 4 is 4. So that is 2 minus 4, that is equals to minus 2, that is less than 0. Okay. So what we are seeing that the dy by dx, this gx, when the gx is greater than 0, that means the numerator is greater than 0, denominator was 0, greater than 0. Okay, when the numerator is greater than 0, so the function becomes what? So the dy by dx become greater than 0. That means there is the increasing function. So the function is the increasing function at value -1, and when the dy by dx is equals to 0, so the dy by dx is less than 0. Okay. So here it is a decreasing function. So the function is increasing at -1 and the function is decreasing at 0. Okay. So there has to be some point between -1 and 0 where the graph has to cut the x-axis. Okay. Then only in the -1 it will be increasing function and at 0 it will be a decreasing function. So there has to be a critical point between -1 and 0. Okay. So the C option is correct and D option is not correct, because D was saying that there is no critical point. So there are two options correct. A, I have showed you that when the x value is -4, the y value is 0. And the C option is also correct, because there is a critical point in the range -1, because at -1 the function is increasing and at 0 the function is decreasing. So there has to be some point at which the graph of the function y x has to cut the x-axis. So the point where the graph cuts the x-axis, that is the critical point. Okay, so I hope that you must have understood the sum very clearly. Okay, thanks for watching the video. Stay fine. Thank you.